Hello everyone. This class, let's introduce the SQL Language Preliminary. This context is a very important context in our course. And first, we will introduce what is a circle to you, and it includes the features of circle and the classification of the circle language. And it includes, we can see that it includes the circle data definition function and the circle data query function and data multiplication function and data control function. These are circle language. And second, we'll introduce the basic data definition, it including the definition, the delete and modify basic tables, and how to give the index and the deletion. And the third, we will introduce the basic data operation, which including the insert, modify, and delete. First, let's give an introduction to the circle. The circle, its full name is Structured Query Language, and we can see in 1974 it was proposed by these two persons, and from 1975 to 1978. It was implemented on System R and developed by Central's Research Library of IBM. And then we can see we got many versions of this circle language. And this chapter, we will mainly describe the usage of the Circle 19.2 language. It is required to skillfully use circle statement to complete the basic operation of database in different relational DBMS. And let's see what's the difference between this relevant standard. And this one, the Circle 2092 is the one we merely to learn. And we can see that it is a superset of Circle 89, which adding many new features such as new data types, richer data operations, stronger integrity and security support, and so on. And it is also a superset of Circle 89, adding many new features. So let's see what's the detailed of this circle language. First, it integrates the data definition language, the data manipulation language, and the data control language, which we have introduced in our previous classes. And the single structure, the relation brings the unification of the data operations. And we can see this circle language, it provides highly emphasized, which means users only need to ask what to do, and they don't need to tell how to do, and do not need to understand the access path. So it is very easy to use. And there are two ways to use, and they have the unified grammatical structure. And we can see the circle language is both a self-controlled language, which is used by users, and an embedded language, which is used by programmers. So here, let's compare what's the difference between the three-level database schema supported by Circle and the three-level database schema in this Spark. So what's the difference? Before we see what's the difference, let's classify what is a view. And views are generated from several tables or other views. And we know a view is a virtual table, which it is actually do not exist. And the view belongs to the external schema and the three-level database schema we have introduced in the first class, right? So view belongs to the external schema, and which is a subschema of the schema of the internal schema. And in the database, there is only the definition of the view, and there exists no actual stored data. And for the storage file of view, we can use this file. So here, let's see the corresponding support of the circle for three-level schema. We can see on the right, it is the three-level schema which we have introduced in our previous class, and we can see the key of a database is of the DBMS is schema, and for its physical storage information, it has the internal schema, and for the user applications information, it has the external schema. So so we can see the corresponding support of the circle for this three-level schema, and for the DB, the database, we have the file, and this one is corresponding to the internal schema. And for the schema, we have these actual tables, table 1, table 2. And for the external schema, we have this a lot of views, and these views are for these users to use. So that is the corresponding information. And we can see for the view, it is the basic unit of the external schema, and it is essentially different from the basic table. This is different, and the view, it is actually do not exist. And the table, which is actual the data, which is stored in the file. And file is the basic unit of the internal schema, which stores the basic table. So here we can see the difference between the Spark three-level schema structure and the database schema supported by Circle. And we can see from these two figures, the difference is in the three-level schema, application can only open one external schema. We can see it is one-to-one corresponding, but not in Circle. And in three-level schema, the application can only access the external schema, which can be external schema and schema in Circle. And here we can see the architecture for our Circle database, and we can see for this, for the users, we have a lot of users, and we have a lot of views, and these are in the external schema. And for this actual table, table B1, table TB1, table TB3, these tables are stored in the file, which in the physical, which is the physical storage level. So here, let's give the formal definition of the SQL language, and we can see it is classified in several languages. First is DDL, which we call the data definition language, and this kind of language is used to create, change, or delete database objects, such as tables, views, indexes, and other objects. And the statement of the operation are including the created. For example, you can use this create a table, and we have the author, we have the draw to delete a table, and for the data manipulation language, they are used, this kind of language are used to manipulate database objects such as tables, and the operations are including the select, insert, update, and delete. And for the query operation, the select function is is very frequent to use. So you need to know these functions, how to use. And the last one is the data control language, which is also a kind of SQL language, and they are used to define control access objects such as tables. And the operations are including the grant and revoke. Okay, so here I have divided these operators of the SQL language divided as by their SQL function. And we can see for data query, we use select, and for data definition we use created, alter, drop, and for the data manipulation we use insert, update, and delete, and for data control function we use the grant and revoke. So you need to remember all these operators, which is very important in in the use of our SQL language. And here, let's see the experimental environment. So if you want to use relational DBMS, you first need to installing one. So here, I show the SQL Server 2000 or 2008. They are the relational DBMS. And for use, we first need to install it, and then we need to confirm it, and then we need to learn the use of the management tools and the utilities for this relational DBMS. So first, how to install the SQL Server? First, you need to ensure that the software and the hardware environment of your computer can meet the needs of the SQL Server. And the second, you need to select the appropriate version and component according to the desired purpose and the software and hardware environment of the computer. So different versions of the SQL Server, they have different functions. Maybe the main function is the same, but they have some functions, select functions difference. And then you need to create an account used by SQL Server. And for the config process, we have first, you need to start and stop SQL Server services, and you need to registering servers and creating server groups. And for the service manager, we will learn the SQL Server Climate Network Unity, and the SQL Server Network Utility. And we have the SQL Server Impress Manager, and we have the SQL Server Query Analyzer. And you can just find the books online to learn this. We have a lot of information about the SQL Server 2000. And from the based on the usage of this, you can know, you can understand the SQL language, which you can use it more. You can use it very well by just download a SQL Server to use. And then we will introduce the basic definition. And for table, the functions of the SQL server, they have created basic table. They have the modification of the table structure, and they have the functions of delete base table. So here I give a data definition function, which is a DDL overview, and we can see that the data definition statement of the circle includes the following statement. And for a table, if you want to create a table, you can just use the language created table, and which is very direct. And if you want to drop a table, just use drop table. And if you want to alter table, just use the message alter table. And for the view, for the operation of view and index, it is the same. If you want to create a view, you can use created view. And if you want to create an index, you can just use created index and so on. But here, we need to notice that for the index, there has no modification statement. So that means you can't just modify the index, and the index is you can't modify it. But for view and table, you can use alter table to modify it. And here about the establishment on and the revocation of the database, we can see if you want to build a new database, you can use the message created database, and we add the database name. And even if you want to undo a database, you can just use drop database and plus the database name. And if you want to specify the current database, you can just use the database name. And also here, we give the method of how to create a database grant manager. And we can see if you use the message created database grid manager, we can see what will happen on the data file and the log file. You can see that if you use this message on data file, we have this information, and we can see they will create a data file which called grid manager data, and here is the file name and the file size and the file growth. And there also something happened about the log file, and also the same. The log file is created as the grid manager log, and they have the file name and the file growth and the file size. And here, we need to introduce the definition of data type, and the data type is divided in character type, which including the char, and the char type is the fixed long string, and the vchar is the variable long string. And for the numerical data, which includes the integer data, it is 8 bytes, and for int it is 4 bytes, and so on. And for decimal type, we have this numeric which is a fixed point number, and we have the decimal which has the same usage as numeric, and we have the currency type such as money and small money. And we have the data type such as the date time and we have the small data type, and we also have the test type and the logical type. So if we want to create a table, we can see what's the semantics. We can see the operation is followed as created table plus table name, and you can also add some. You need to also add the column name, the data type, and the primary key, which is the keywords, and the foreign key, which is the foreign keywords. And also you can add the reference, which is the table name. You need to provide the table name of the foreign keyword. And then we can also add the check information about the verification of the conditions. For example, if you want to establish the student relationship, we can just use the following language. This is the data definition language. We use the created table student for the purpose of created a table called student. And here we need to give all these column name and the data types. And we need to give the information of the data type, which can be none or cannot be none. Here we need to give a very clear definition. And for another example about the created employee table, we can see that if you want to create a table like this, you can just use created table employee. And here, this one are the column names. And here, you also need to specify the data type, and also not none or can be none. And also if it is need to be unique. For example, if you can use this key, it must follow a unique value. And here you can just give a default value of a column. For example, you can default it as a male. So for the default value of sex will be male if you just set this definition. So if the customer table name or the column name is composed of phrases containing multiple words, you may choose to use brackets or double quotation marks to encode the table name or the column name. For example, if you want to create an employee table 2 where the table name or column name contains multiple words, you can just use this one. For example, you want to create the column such as the employee number or the employee name, you can just use this one. You can just use the quotation marks such as that, or the brackets such as that. It just represents a column which containing multiple words. So here, let's see how to create a new table based on the query results. For example, let's see the example below. If you want to create the female student, girl student, this relationship, we can just use created table, girl student. And here we have as the query clause, and we also have this column name, and we have this this is a SQL language, which as a query language. So that means when we obtain the query results of this query language, we can use these results to create a table called table student. And we can see the detailed implementation in the server, in the MS SQL server. It can be select as number, as name, as age, into they use into to show they use this into operation, which we need to notice. And from the when you into group student from student table, where the connection is sex should be female. And for the functions of table deletion, we can see the grammar is drop table. And here we can use, you can just delete a lot of tables at one time. You can just write table 1, table 2, and so on. And the explanation is, as soon as this sentence is executed, the specified data table is deleted from the database. So it means the table is deleted, and the definition of the table in the data dictionary is also deleted too. So for the indexes and views created on this table are also automatically deleted. So this drop table statement can delete multiple tables at one time, and the multiple tables are separated by commas here. So we can see if you use the operation of drop table, it deletes the table, and as well as all its related information such as indexes and views. And here we need to classify the difference between the operation drop and delete. And for the operation of delete, it clears all data rows in a table. For example, if we want to delete table, you can use drop table student. And about the sentence of modify table structure, which I just give this schema, the grammar here. And we can see the operation add here. Add a new column or table level integrated constraints to the table. And this specific precisions are equal to those of created table. But the new column must be allowed to be empty unless there is a default value. And for the job here, the job column, it is used to delete an original column in the table. And for the operation of alter column, it is used to modify the data type of the original column in the table. Generally, when there is a constrained definition on this column, the data type cannot be modified. And also for the drop constraint, it is used to delete the original table level constraints. So here, let's see how to add a column to a table. We just use the alter table operation. And here we can write the table name, and also we can write the added column name and its date type and other information. For example, if we want to add a column of address to the student table, we can just use alter table student. And for this table, we can write add attribute address and give the format of char 50. And for the example of add a column of person in charge in the employee table, we can use the alter table employee and add the immigrant car, and we specify the value can be none. So if data already exists in the original data, the original table, the newly defined column must be set to none, unless there is a default value, which we need to notice. And for the operation of delete column on table, it is the same. And you also use the alter table plus the table name, and you need to specify the column you want to drop. Just use drop column, add column name. So if you want to delete the newly added address, you can just use alter table student and drop column address, which is a very intuitive. And also, if you want to increase a column, you also need this alter table and alter column to increase the table. So for example, if you want to modify the data type of the column be placed in the student table, you can just use alter table student. And then you use alter column be placed. And the format is char 30. And the condition, if the condition is the column is empty, we need to change the data type and shorten the length. For example, if you want to modify the data types of column imager to char 10, you can just use alter table employee and alter column imager char 10, which is very direct. And here we need to notice is that we only need to modify the data type, and we have no need to modify the column name. And if the data already exists in the column, the data type cannot change and the width of the column cannot be shortened, but the column width can be increased. You know, if we have the data, we cannot shorten the column, the width of the column, but we can increase the column width. And here we also give a simple introduction about the modification constraints in the table, and we will introduce it in chapter 4 for details. And for adding a constraint, we can use alter table and add constraints, and we add the constraint name, and we need to specify the detailed information of a constraint. For example, if you want to add a new uniqueness constraint, you can use to the table student, we can use alter table student, add constraints, add what constraints? We named UQ be place to be unique of be place. So that means we define a uniqueness constraints called UQ be place for the column be place. And for the function of delete constraint, we can use these similar operations. And we use alter table name, and we need the information of the constraint which you want to drop, and we will use the constraint name here. So if you want to delete a new uniqueness constraints, you can just give the alter table student and drop the constraints you'll be place, which we have which we have defined here. And here for the function of rename, we can use this. We can't use this alter table statement because the alter table statement does not support the modification of the column names. So if you want to rename the column names, you can use the system storage procedure sp rename to complete. For example, if you want to rename the table employee2 to the EMP, you can just use this execute as exec, and we need to specify the sp rename and rename what? Rename from the employee2 to the EMP. And here the system start procedure sp rename can also rename the table name. And here, if you want to rename the here, you just here is the function of rename the table name, and here is the function to rename the column of a table. For example, if you want to rename the column employee name in the EMP table to E name, we can just use exec sp rename emp this column name we call the employee 8 employee name to ename. And then let's study the basic data operation, which includes first for the data update operation. We use insert to add tuple to the table, and we use update to modify the data in the table, and we use delete to delete tuples in the table, and we also learn the data update with subquery and the how to modify data through a view. First, about the insert data, we have the basic semantics like this, and we have two methods. First, we can use the values keyword to assign values directly to each column. Or you can use the select clause to insert data selected from other tables or views. And it must be noticed that the order and date type of input items must be consistent with the order and the date type of the columns in the table. And you cannot assign values to all the columns, but the columns without assessment must be columns that can be empty, and the columns with default values or identity columns, so on. And the character and date values should be inserted in single quotation marks. For example, if you want to insert a row of data in the specified table, we can use insert into this table name, and insert the information we call values, which is a constant list. So here we give the implementation of the statement. If there is an attribute name list, each constant in the constant list is the corresponding value of these attributes in the new records, which we call one-to-one correspondence according to the position in the statement. However, when the table is defined, the column with a description of not none and no default value must appear in the attribute name list. Otherwise, error will occur. And if there is no attribute name list, The constant list method assigns values to each attribute columns in the order of the attributes in the table. So there should be, for this condition, there should be attributes on each attributes column. And in the constant list, string constant and data constant should be enclosed in single quotation marks. Here, we give several examples. First, if we want to insert employee record in the employee table, we can use this insert into employee table. And the values is 2008 and its name, and its sex is male, and the age is 78, and is here also attribute called 1, and is an engineering. And we have the attribute value called 01. And here, if we want to insert a new employee in the employee table, the employee information is Song Wenbing, number 2003, male. We can just insert into the employee. Now we call the employee. The added employee information is on these 3 columns. We specified as e number, e name, and e sex. So we can add the values of these 3 detailed column values. And here we give the solution of use insert multiple lines with the select statement. So that's how to use this tool statement to insert multiple lines. First, data selected from one or more tables or views can be added to the table. So you can just add data to one or to some or all of the columns in a row. And the result size of the slogan select clause inserted in the table in the data must be comparable. That is must be compatible. That is the name. That is the number of columns under order, and the data type are compatible. And here, for the functions of update data, we have the statement for Mars. And first, we need to specify the table name on which you want to update table. And we need to cite the column name as some kind of impression which you need to update. And here, we also need to give the condition, which means if the condition is satisfied, then the update operation will be processed. So this statement modifies the values of one or more columns in a record that meets the condition. And you can use the set clause to specify the column to be modified and the modified data. And when no modification condition is specified in the where clause, the specified columns of all rows in a table will be modified to the new data given the set clause. And the new data can be specified constant or impression or data from other tables through the select clause. For example, in the payroll, if we want to increase the basic salary of all the employee by 50, we can use update salary, which is a table name, and we need to set the base pay is equal to base pay plus 50, which we use this to modify the value of multiple tables. And another example, if we want to revise the employee Hu Yiming to Hu Yiming, we can use the following statement. We can use update employee, and we need to set the name to Hu Yiming. Where is the condition if its name is Hu Yiming. And the statement format of delete data is here. We need to specify the table name which you want to delete data, and we need to give the condition. So its explanation is that if where condition item is specified, all the tuples that meet the condition of the where clause will be deleted from the table. And if there is no where condition, all the records in the table name will be deleted. However, the structure of the table is still there. So the structure, including the attributes constraint, it is still there. But there is no records and it is an empty table. For example, the employee record with number number of 1003. If we want to delete it from the employee table, we can just use delete from employee where the number is 1003. And another example, if we want to delete all records in the employee, we can use delete from employee without any condition. So they are also do very simple. Then we will introduce the basic data definition. First is the index. We will learn how to create the index and how to delete the index. Before that, let's give the several information about the index, which including the concept and the function of index, the type of index, and how to create it and manage indexes using the enterprise manager, and how to create it and manage indexes using the T-circle statement. And for index, whether the index is designed efficiently is one of the factors affecting the performance of the SQL server. And we can see a well-designed index can significantly improve the performance of a SQL server. And what is the function? What is the function of the index? We can see when the indexes column is used as the query condition, the index can greatly improve the execution speed of the SQL statements. So if we compare a basic language table to a book, the index is like a book dictionary. So by querying the dictionary, you can find the page number of the relevant chapter so that you can quickly find the content of that section. The difference is that the basic table can establish more than one index, and it can establish multiple indexes according to different attributes or expressions. And the index also has the advantage of accelerating the execution of order by and group by statement and forcing the uniqueness of rows. For example, for this table, if you want to the added indexes is like this. The added indexes for this table. The indexes are like this. So we can see the index and the table, we have a detailed corresponding relationship. And here we give an example of the index. Here we give this is record which need to be inserted. So if we want to insert this record to this table, the simple method is to check the uniqueness of the primary key with full table scanning method. And the disadvantage of this full table scanning is very intuitive, and we can see that it is very time consuming if you just check the primary key with the full table. So in order to avoid the full table scanning of the basic tables, the relational DBMS core generally automatically establishes an index on the primary key. So we can just build B tree index, and then the efficiency can be improved by searching whether a primary key value already exists in the basic table through the B plus tree index. So if the primary key value of the newly inserted record is 25 through the primary key index, search from the root node of the bija tree. And we read three nodes. First one is the root node, and then is the intermediate node, which we call 12 and 30 here. And this is the root node. This is the intermediate node, and this is the live node. So here we can see that the primary key value already exists, so this record cannot be inserted. So here we use index to check the uniqueness of the master code, the primary key. So here we give the concept of index. The index of SQL Server is a physical structure which can provide the ability to quickly find rows in a table based on the values of one or more columns. And the indexes can be created when the table is defined or at any time after the table is defined. And indexes can be created on one column and a combination of columns. Or different indexes can be established on multiple columns of the database table. So although the indexes are important, the more the better. It is not the more the better. This is because creating an index takes time and takes up storage space. And although the index speeds up the retrieval speed, it slows down the speed of data modification. Because if you want to modify a table, the corresponding indexes should be changed too. And for the conditions where indexing may not be considered, we just give a summary, such as the column that are rarely or never used as query criteria. And for this condition, you don't need to consider building index. And if finding rows by index in a small table may be slower than a simple full table scan. So this may happen too. And for the columns that only take values from a small range, you don't need to build index tool. So where the index should be used? When considering whether to create an index on a column, you should consider what role the column plays in the query. So following situations are suitable for creating an index. The first is the columns used as query criteria, such as primary keys, and also the columns frequently searched by range, such as where quantity larger than 5 or and also smaller than 20. And also the frequently used columns in a join. And here for the type of the index, according to the structure of the index, we have the clustered index and the non-clustered index. And according to the functions realized by the index, we have the unique index and the non-unique index. And here, let's give the detailed introduction. For the clustered index, the physical storage order of rows is exactly the same as the index order. That is, the order of indexes determined the storage order of rows in a table. And each row can only have one clustered index. And the clustering index is conducive to range search. So if no other clustered index is created in a table, the clustered index is automatically created on the primary key column of the table. And for the non-clustered index, the logical order of indexes is not the same as the storage order of rows in the data. An index simply recorded a pointer to the position of a row in a table. And a non-clustered index exists as a separate object from the table, and the non-clustered index can be defined from each row in the table that is commonly used for queries. And good for queries that directly match a single connection, less suitable for queries that return a large number of results. And creating an index for a table is a non-clustered index by default, and setting a unique constraints on a column also automatically creates a non-clustered index on that column. And here we give an example how if the clustered index is not established, we add a record to the table like this. And if we created a clustered index on the CNAME column, then after the clustered index is established, a new table is formed by adding a record to the table. It's this one. And for the type of the index, for the Unicode index, it ensures that duplicate data is not included on the column or a combination of columns that build the index. Both clustered and non-clustered indexes can be Unicode indexes. And the Unicode indexes are automatically created on columns for which primary key constraints and Unicode constraints are created. So let's give an example. If we created a Unicode index on the CNAME column. So here is the results. And after the Unicode here the results, we can see that we can't add another same value to this CNAME column. But after the unique index is established, a new table is formed by adding a record to the table. So here we can see that it is not allowed because this attribute value of CNAME is the same. So here, let's see how to create an index. The statement format is like created, unique, clustered, and non-clustered. These things you need to cite. And also the details of the index, including the index name and the table name and column name, also about the order and so on. And here we give some instruction. The LC ascending represents accessing, and the name DESC represents the descending, and the default also is the ASC, ascending. And the clustered is a clustered index, and there is only one for a table. And non-clustered is a non-clustered index. And Unicode means a Unicode index. For example, if we want to create an index by the course name of the curriculum, we can use created unique index course name on course CNAME. Also, another example, if we want to create an index for the employee table, first sort by department value and then sort by employee number in descending order when the departments are the same. For example, we can use created index employee as in EMP on employee. And these columns are also specified. And also the statement format of the job index while including the index name. And this statement will delete the specified index, and the index description in a data dictionary will also be removed. And the index name specifies the format of the table name, view name, and index name. You use this format like this. So if you want to delete the IXEMP index, we can simply use job index employee IXEMP. So if you want to if you want to search the index, you can use the in enterprise manager. For example, you can use the T-circle system, which stores the procedure SP help index. It will returns the name steps and indexed columns of all the indexes on the table. For example, if you want to view information about all the indexes on the employee table, you can just use EXEC, which represents execution SP help index employee, and it will return the information of indexes. So in this class, we have introduced the SQL language, which we have studied the data control language is used to create, alter, or delete database objects, and we give the operations created, alter, drop, and we give the concepts of index. It's including the clustered index and the non-clustered index. And we discussed the DML is used to manipulate the database objects like tables, and we can use these operations as select, insert, update, and delete. And these are all main functions of the usage of. First, let's see what does it mean by query data. And the meaning of query is get data from database. So the most basic way is to use the select statement. And most select need to include the following components to describe what result site is returned. For example, which columns are included in the result site, and that is which columns of data are to be taken from the table. Second, under what conditions to fetch data from the table, and that is the conditions under which the rows in the table are included in the result site. The third, which tables to query. You query which table and the logical relationship between the tables. Last is the sort order of rows in the result site. And in the following of this class, we will just learn how to do this. First, let's see what is a select statement. The most basic select statement form is like this. It lets select, we put a select list here from a table source here, and the select list specifies the names of the columns to be included in the result site. It is separated by commas, and the table source it names the name of table to be queried. So here you will write the name of the table or the tables, and here you will write the names of the columns in these specific tables. So let's see the complete semantics of the select statement. We can see there is a lot. Besides the select and from, we also have the where, which you need to put the search condition here. And we also have the group by, and have having, and have order by. And this group by is used to group the result you want to query, and the order is it means to order the results you want to query. So here I have give a very simple description for these parameters. For example, for the parameter or, it indicates that all rows in the table will be returned. So if you write or after the statement of select, it will return all the rows in the table, including the duplicated rows. So it is the default and do not need to write explicitly. And then we have the parameter distinguished. It is only unique. It means if you use this parameter, only unique rules are returned. So this clause may only be used once in each select clause. And here the from, it means we will give the table from which the field specified in the select statement was obtained. And here where means you need to give conditions for selecting records from a table. And group by, it means the rows returned by the query will be grouped by the value of a column or columns. And here have is always together with the group by, and it means to give the conditions that each group in the result set must meet. And this clause is only used in the conjunction with the group by clause. And the last one is order by, and it arranges the query results in the ascending order. We call it ASC, or the descending order, DESC, according to the value of a field or several fields. So let's just learn how to use these kind of parameters in a select SQL language. first, let's see how to query all the information in a table or in a relationship. And below, I will give several examples to show how to use a SQL language to achieve so many query functions. So the example I used, I have 5 tables, and I will use several different select language on these 5 tables, and I have shared these 5 tables to you. So when you just listen this course, you'd better to open this 5 table and just see the example together with me. So first, if you want to query all the information of the employee table, it means the table 1, or we can see we just select the ENO, name, sex, age, is married, title, and we can see these are all the attributes of the table employee. So if you want to query all the information in the employee table, you just need to write all these attributes, all these columns in the employee table. Just put from employee. So then you will get all the information, all the rows in this table. It will return all the rows in the table. And this statement can be replaced with the following statement here. You can just use a very simple star to replace all the columns in the table, and it is, we can see that if you every time if you want to query all the information, you need to write all these columns. It's very complex, so you can just use a star to replace it. And then if you want to specify the column you want to query, you can just, for example, if you want to query the job title, the job title of an employee, then you can just put the attribute name title. We can see in the table 1, the last column. So its attribute name is title. So if you want to query, just want to query this title, you can just write select title from the table employee here is okay. And then we'll learn how to use the distinguished keyword to remove the duplicate rows from the result site. For example, if you want to eliminate the duplicate rows in the result site, you can just use select title from employee. So we can see these results may return you several duplicate rows, and the same as select all title from employee. We can see for this title, there are many employees who have the same title. So if you just write this kind of SQL language, it will return the whole columns to use, which include many duplicate rows. So if you want to just eliminate these duplicate rows, you can just add distinguished before the columns which you want to eliminate the duplicate rows. So you just put distinguished after select and before title is okay. So here it will return the clean result, which may only contains the rows which not duplicated. And then let's see how to use the constraints and the calculated values in the result. For example, this result, this SQL language means you want to query these 2 columns, ENO and the title from the employee table. But if you want to query the name, year of birth, and the title of employee, which you need to write, we can see that in our table one, the employee table, we don't have the attribute called year of birth, but we have the attribute age. So if today's year is 2010, now then if we want to obtain the year of birth of each employee, we can just use 2010 minus age, so we can obtain the year of birth. So here you can just write you want to select a name and this column and 2008 minus age these columns and title these columns, these three columns from the employee. So here we can see that although this SQL language allow this kind of equation, but it will return no column name, which may not be the thing we want. So we can just give it a name. For example, in this SQL language, we can give it a name as year of birth. So it will return the column name year of birth, and it is equal to year of birth equal to 2010 minus age. So if you use this kind of SQL language, it is also okay. And then we will learn how to assign Alex to columns in the result side. And then let's see the example 6. How to assign Alex to the columns in the result side. For example, we can just select ENO as drop number and title as 这个 drop number from the employee. So this is equal to select drop number is equal equal to ENO and the job title equal to title. So these two solutions is used to assigning the Alex to the columns, so we can get the query results more clear. And next, we will learn how to use this conditional select query. So the basic semantics is select from, which we have learned. And here we need a where. We need a where clause, means where. And here we need to write the search condition, and which is the conditions for selecting the query results. And for the SQL Server, which is a relational DBMS, which is widely used. This SQL Server supports selection methods such as comparison, read list, and string matching. And let's see the first select query result based on the comparison. For example, let's see the example 7. Query the names and ages of all the engineers. So here we need to know we need to query the names and ages of the engineers. So for the person who is not an engineer, we don't want the result of their name and age. So here the condition we will write their title should be engineer, and here we also write the same and select ename equal to names, and age here is age from employee is from the employee table where title is engineering. And for the example 8, how to query the status of all the projects completed before the end of 2009. Here we can see is table 2, the item table, and here we need to write select start, which means we need to obtain all the information in the table from the item where the end date is before the end of 2009. So here we write 2010, the first day of the 2010. And for the clause where, in addition to these comparisons, the following keywords can be used in the where clause too. Here we can see we can use the keywords in, which means determine whether the value is within the given range, and not in, it determines whether the value is not within the given range. And that like, we can also use like, it determines whether a value is similar to a given value. And the same not like means determine whether a value is not similar to a given value. And it's none, it means determine whether the value is empty. And it's not none determines whether the value is not empty. And determines whether the conditions given on both sides of the and are met. And or means determine whether one of the conditions given on both sides of or is satisfied. And between and determines whether the value is between the given values. And not between and determines whether the, here is between, determines whether the value is not between the given values. And here we can see if we use the between and keywords, how to use that. Let's give an example. For example, query all the projects starts in 2008 to 2009. So it's still the table 2, and here, as it didn't specify the columns we want, so we just put a star here to represent we want all the columns. And from the table in term where, here the condition we need to write is the start date. The start date is between the 2008, the first day of the 2008 and the last day of the 2009. And let's see the next example. If you want to find tuples whose base pay, which means the basic salary is not between the 500 and 700 from the salary table, and display all the attributes of the eligible tuples, which one we need to use. We can see here we also use select and we use the star, means we want all the attributes of the tuples. And from the table, which means salary, so we write salary here. And here the condition we need to write is the base pay. Here the base pay is not between 500 and 700. And then let's see how to select query result based on the list. And first we see how to use the in keywords to query the columns that match any of the values in the list. The list following the in keywords can be a constant or the result of any another query, we call it a subquery. And we also see an example, query the name and the department number of the employee with the title of the engineer or above. Which one we need to use? So we will use select e name which means e-name, and the department number, the DNO, which means department number, from the employee table, where the title is what is engineer or above, or the title is senior engineer. So this is equal to the title in, which means in this domain of engineer and senior engineer. And here we need the select query result based on the string matching criteria. So it means that fuzzy matching of the strings can be done using the like operator. So the basic semantics is select list from table source and where the expression like a string. So the expression is the column or the expression used as the selection condition. And the wildcard characters can be included in the specific string, including here. We need a percent, represents any number of characters. For example, we can use this. We can use these characters and write Jing. So it means you can. We want to search. We want to search any string which included GING. And we can use this underline to represent a single character. And we can also use this to represent a single character within the specific range. And we can also use this character to represent a single character in the range that is no longer specified. For example, like this one. So we also give examples to show how to use this kind of strings. First, if you want to find the item name that contains performance research in the INAME. So INAME is the table 2 from the item table. So we can use select INAME from item on this table where the INAME like performance research. We add this percent character here and here to represent this kind of thing. And for example, next example, if you want to find the employees with email address on hotmail.com, so we can use select ename DNO from employee where their email address is like here. We can use a percent character and before this hotmail.com. In the next example, if we want to view the department name whose first phone number is not 8, we can use select. We will select EDNO, the name from employee where their phone is like not 8. So here this we write here means not 8. The first chapter is not the first number is not 8. And here we use a percent to means that the following numbers it could be any numbers. So let's see how to select the query results based on the unknown value. This none. So none represents a non-value. It's an unknown, non-exist, or imperishable data. So you can use is none or is none to test whether a column is none. So you can just query all customers with email addresses to use the following SQL language. Select name the enroll from employee where the email address is not none. And what about select the records whose identification date is not empty from the item data? So you can just select star from item where the check date is now none. And we can also select query results based on multiple criteria. For example, in the where clause, you can also use logical operators to connect multiple conditions. There are mainly logical operators such as and, or, and not. So for example, how to select tuples from the salary table that meet the following conditions. First, the basic salary is between 600 and 700. Two, second, allowance are 600, 700, and 1,300, 2,500. And the first three digits of the employee number are 100. So if you want to select tuples which satisfy all of these three conditions, you can use the operators AND. So it will like this. It will like select star from salary where the base pay, which is corresponding to the first condition, base pay between 600 and 700. And the second condition is corresponding to this service in this domain, in this 600, 700, and 1,300 and 2,500. And the third condition is corresponding to this one, their ENO, which means their employee number is like 100. Here we can use underline mark because all their employee, all the ENO number of their employee, they only have 4 digits. So here we have three digits. So here we can just use underline to represent we need another number. Is enough. So then let's see how to sort the query results. So for default, the order of the rows in the query results site is the order in the table. But if you want to sort the query results, you can use the order by clause. By using this, you can change the order in which the query results are displayed. So the grammar is, the semantics is select list from table source where search condition. This is the same as we have learned before. Here we will write order by, an order by expression, and here we will write this order is accessing or disaccessing. So the order expression is the column name or the column number to sort by. And ASC means the accessing number, and DESC means the decising order, and the default is ASC. So if you want to order the query results by the accessing order, so you don't need to write this ASC. Otherwise, you need to write this DESC. So what about if you want to return the limited results? You can use this top N. So top N means to return the first N results of the query. And if you use this percent parameter, so N will represent the percentage. So let's see the example here. If we want to query the names of the 3 projects with the highest cost and their cost is what? Just return. So we will use select top 3, name, outlay, from item, order by what? Order by the outlay, which means the highest cost, and we will use this desizing order. So we put DESC here. And multiple columns can also be included in the order by clause. For example, the query results are first sorted in descending order of department orders numbers, and those with the same department numbers are sorted in the order of age. So by query this example, we can use select star from employee table where is Mary is 1 and ordered by the DNO. DESC means deciding order and age. So here, for the query language, we also have the aggregate function. So aggregate functions calculates the sum of the data in the table to obtain statistical results. So the SQL Server provides the following aggregate functions. The first is count. So count means count the number of the tuples in the result. And we also have this count, which we will specify column here, means count the number of the tuples on one column. And here we have the max and mean here falling with their column name, means the maximum value on a column or the minimum value on a column. And here we also have the sum average. For the sum, we have also falling with the column means the sum of the values in the column. And this function is only effective for numeric tabs, which means continuous tabs. And for the average, it's the same. It means the average of the values in the column. And it is only effective for the numeric tabs. And for this example, count the number of records. Or we can use just select count star from the employee to get the number of records in the employee table. And here we will write select count title from employee to get the number of titles, this title column. And we will write select count distinguished title from employee means you will get the number of the job titles. So here you use the distinct to means you will remove this dominant columns, dominant rows, so you can get the number of the job titles. So here let's see the example. Find the total cost, average cost, minimum cost, and the maximum cost of all the projects. We can use the following query language. That means select sum outlay, which means you will sum the column outlay as the total cost and the average outlay as average cost, and the max outlay as the highest cost, and the mean outlay as the minimum cost from item. Also here we also have the data project pocket, which we have group by, we have having, we have compute and compute by. First, let's introduce the group by. The query results can be grouped according to the certain conditions, and then the statistical information can be calculated for each group of data. And the purpose of grouping query results is to refine what the set functions works on. So generally, the group by clause is only used when there are aggregate functions, is count or sum, in the target column expression of the select. So the grammar is select list from table source where the search condition. Group by, here you need a group by expression. So here the notes on using the group by clause is you need to make the consistency of the targets in the select clause. So you count max multi-row targets with the aggregate functions. So here, if you use select title means you need a multi-row target, and here count in O means you use a aggregate function. So this is not allowed. This is not allowed to write these two things here together, and this is a sentence grammatical error. So the columns in the select list are included in aggregate function group by clause. So if it is not allowed, we can correct to the right query language like this. If you want to query the number of employees who belong to each professional title, here you can use group by title. So here, if you use a group by title, we can just count the number of the employees inside to each title. And let's see the next example. Group the tuples in the employee table by department and calculate the average age and output the two columns of the department number and the average age. So here we can use select in and all average age as average age from employee, and here where. We don't want where, and we can just write group by in and all, it's okay. And we can also group by multiple criteria. And we can see if we want to query the number of employees with each title in each department, we can use select in all title and count in all from employee, group by in all and title. So here we can use two columns after the group by, and here we can use it means it will grouped by in all first, and then it will group by title. And here we can order by DNO title in a descending order. And here we will introduce the use of the having phrase. The semantics is select list from table source with search condition, group by, here we use group by expression. Having means the search condition for the group by. And the last one is order by. So for the having phrase, it is used to add data formatting criteria to queries using the group by clause. So the difference between the where clause and having clause is that they have different working conditions. First, the where clause acts as on the base table or view to select tuples that satisfy the condition. And for the having phrase, it acts on the groups from which to select groups that satisfy the condition. And they have different execution times. And first, the group by clause removes the rules that cannot meet the conditions in where before grouping, and whereas the condition in the having phrase is applied after grouping. And the different use of the aggregate functions is the having phrase can contain aggregate functions in the condition, but the where clause cannot be included. So we also see an example, query the departments whose average age is less than 40 and the average age of the department. We can use select in all average age means the average age of the department as average age, or we give it a name, from employee group by in all. So the condition is having average age is smaller than 40. And the next example, query the name of the department whose total basic salary is higher than 2,000 and the specific total number of payment. So we'll use select the name sum base pay means the total basic salary is higher than 2,000. So here we use a join. We use a join connection between multiple tables, which we can just put here. And if you don't understand, it's okay. We will introduce it. We will introduce the connection, how to make relationship between multiple tables later. And here, let's see, it's grouped by the name. And the condition is having sum base pay is larger than 2,000. And for the compute and the compute by, we have the compute clause can be used to calculate the aggregate data. The query for compute returns to two result sites, one containing the detailed records of the data, and the other one is the summary records. To compute by can group query results by giving criteria and calculate summary non-summary data for each group. So if compute by is used, order by must be used, and the order of the columns that appear after must be the same as the order that appears after order by, or a subset of it. So let's see the example. Another example. Let's query the project funds established after 2008 and count the total funds. So we can select the sum outlay from item where the start date is after 2008. So if we want to compare the query results, we can just put compute sum outlay here. And another example, if we want to query the number of people in each department and the total basic salary distribution of each department, we can use this one. here is the example below. And if we want to compare the query results, we can add the order by the name, which compute count in name, sum base pay by the name. Here we need to notice that here the column should be the same with the order by column. And then let's see how to query data from multiple tables. That means the table join. We will use the table join to query data from multiple related tables. And the first is the join condition, and the conditions used to join two tables are called join conditions or join predicates. And for the common formats, the table name, the column name, and the comparison operator, it's like this. And the comparison operators are here. Equal is smaller, is larger or smaller, and so on. And the join field is the column names in the join predicates are the join fields. And the join field types in a join condition must be comparable, but not necessarily the same. And for the tab of the join query, we want to generalize the products. We need just call the cross join, and we need the equivalent connection, which including the nature connection. And we use the non-equivalent connection query, and the self-connection query, and the external connection query, and the compound connection join query. And first, let's learn it one by one. First, we specify Alex for the table name in the from clause. So we know for multiple tables their name which one to refer. So the format is the table name Alex or table name. Let's see the example. Specify Alex for the table name in the from clause. So here we can use select name from employee as E. Here we use this function to represent we give a name E to the table employee. So we can also use select this is the same, and from employee E. So here you can just automate the as. And for the cross join, also we call the unrestricted join. It combines two tables without any constraints. That is the generalized parsing products of two tables. The number of rows of the result size obtained after cross join is the product of the number of rows of the two connected tables. So the grammar is select list from table cross join tables 2, or select list from table 1, table 2. We use a dot to represent this kind of cross join. For example, if you want to use the cross join query of two tables, we can use select name, title, DNO, the name from the employee the department D. So these are the names we give for these two tables. Then let's introduce the equal join. It means only rows that match in both tables will appear in the result side. So the equal join is the equal join means the concatenation operation with the concatenation operator equal. So it is like this. You write the table name 1 here and dot the column name 1 equal to the table name 2 to the column name 2. So when referring to the attributes of the same name in table 1 and table 2, in any clause, the table name must be prefixed, and the table name prefix can be added or automated when referencing a unique attribute name. And the join connection of the table often takes the form of primary key is equal to external key. So the grammar is select list from table inner join table 2 on. Here the condition is table 1 dot column 1 is equal to table 2 dot column 2. And the select list from table 1 dot table 2 where here the condition is the same with this one. So you use this one or this one, these two formats is both okay to represent the inner join. And the inner join also we call the natural join, and the special case of the it is a special case of the equijoin, which removes the duplicate attributes columns in the target column. So the condition is also the table name 1 dot column name 1 is equal to table name 2 dot column name 2. And we need to know that the select statement cannot directly implement the natural joins. And let's see example. For the example 28, which we have seen before, the output, if we want to output only joint tuples with equal department numbers in the employee and department tables, what we will use? We will use select ename table and eDNO, ddno, dname from employee E, inner join, department D, on ENO is equal to D, DNO. So the join types and conditions can also be specified in the where clause. So here we can also use a where clause to specify the join types and conditions. And for the above example, use the natural connection to achieve. We can use here. Here it is what we can use. And then let's see the execution process of the connection operation, which included the nest loop, the sort merge, and the index join. And this part is only introduced to you to know that it's enough. So we can see for the nested loop, it means to select it star from S and SPG, this one, and this one, where S as an O here is equal to SPG as an O. So this column is equal to this column. So the results should be the first, if we have the as one, so we can have this, which these attributes are from the table S, and this attribute is from the table SPG. Then we have this one to this one is also a match, and we have the following ones. So it is just a loop to affirm that there exists an tuple which satisfies this condition. So the next loop first finds the first tuple in table 1 and scan table 2 from the beginning and finds the tuples that satisfy the container one by one and specifying the first tuple in table 1 with the tuple to form the results A tuple in the table. So after all the searches in table 2 are completed, look for the second tuple in table 1 and scan table 2 from the beginning to find the tuples that meet the conditions one by one, and the tuples are concatenated to form a tuple in the result table. So it will repeat the above operation until all tuples in table 1 are processed. And then let's see the sort merge. The sort merge means we will search if anyone which have the same, which satisfy the condition, and here we have the results. And the sort merge is often used for the equal join, and the first sort tables 1 and table 2 by join attribute. And for the first tuple in table 1, scan table 2 from the beginning and search for the tuples that meet the connection conditions in sequence, and then splicing the first tuple in table 1 with this tuple to form a tuple. When encountering the first tuple in table 2 that is greater than the value of the connection field in the table 1, the query on table 2 does not continue. And found a second tuple in table 1 and then continue to scan the table 2 sequentially from the breakpoint just now to find a tuple that satisfies the connection conditions. After finding it, splicing the first tuple in table 1 with the tuple and forming a tuple in the result table. So when directly encountering a tuple in table 1 that is greater than the value of the connection field in table 1, the query on table 2 does not continue. So it will repeat the above operations until all the tuples in table 1 or table 2 has been processed. And then let's see the index join. So it will be very complex. So we will use a B tree to represent the index for the table of SPG. And it will see, we will just search for each column in the table of S. It will search the index one by one to find if have someone match. And then let's see the non-equal join. The non-equal join, here we can see the concatenation operations where the operator is not equal. So the form is like this. The form is like this. The column 1 dot the table name 1, column dot the column name 1, and here we have the comparison operator, and the comparison operator will be here. It means the larger than, smaller than, and this so on. And we also have the between and. So here, let's see example. Suppose there is a salary scale and query the salary and salary scale of each employee. We will first create a salary scale table like this. We will create a table for to have these 3 attributes, and here they are their data type. And the non-equivalent connection solution should be select in all base pay grade from salary segregate, where base pay is between low salary here and high salary here. And for the outer join, in the outer join, you can limit it only one table and not the other table. Means all the rows appear in the result side. And the outer join are divided into left outer join, right outer join, and the far outer join. And the left outer join semantics here is that select list from table 1, left outer join table 2 on table 1 dot column 1 is equal to table 2 dot column 2. And it's similar for the right outer join semantics. Here, for the right, you can write it right here, and the condition is same. And for the full outer join semantics, it means here you use point to replace the left and right, and here the condition is the same too. So these are the whole constant of this class, and I will leave a homework. I will leave a homework now in this class, and please I will just upload the homework on a platform which may be more convenient for you to answer on that platform. Thank you.